I was inspired by a video from Brian Locke to make another power supply. If you haven't seen that video, I'll link that up above so you can go and have a look at it. So what he did that I find really interesting is he was using one of these. So this is a USB power delivery regulator kind of thing. So you put a USB-C in there, and I don't know if you know, but the USB PD standard allows the voltage to change, so you can switch up from 5 volts, which is the normal USB voltage, and you can switch up to, I think it's 15 and 20 volts, so you can have 100 watts of power going into a USB interface, and that's starting to be used by a lot of laptops now. And later on I'll get out a laptop power supply that has this 100 watt output, and we can try it out. So this you can plug this into USB, and it will support a variety of voltages. So I'm going to make a power supply that uses USB PD, like Brian Locke basically. So I've got some components, some very similar to the ones that Brian had. So I've got these nice plug posts, so that are going to be the output. I've got a little on-off switch, and of course the most important thing is the buck boost converter. So this one here, the ZK4KX. I've also got a suitable plastic box here that I thought that I might use to mount all of this stuff into. So the purpose of this video is just to kind of go through some of the things here, and you know, start to do the work to test whether this is actually going to function as I want it to. So first of all, the buck boost converter. So this one actually arrived in a damaged package, and you can see here it has sustained some damage, so I'm quite curious to know whether this will actually work. So you can see it's been dragged there, and the part of the aluminium heatsink has been scraped off, and that obviously won't do it that much harm. But if you look at this capacitor here, the lid of the capacitor has been scraped. I mean, I don't think it's actually broken through there, and the top of the can there is still intact, but it's not very pretty. We'll see if that's had any negative effect. And also the big inductor here has obviously had some scraping. I don't know if the sort of non-conductive coating has been broken through. I suspect it has, but again we'll have to see if that inductor is in good condition. So I'll connect this up to 20 volts, I guess, or maybe a bit more, because my power supply goes up to about 25, my desktop power supply. So we'll try that and see if the thing lights up. So I'll screw some wires in here. Got my Poundland screwdriver, similar to the one that Big Clive uses. That seems quite firm. So we've got positive is the red wire. So let's put on the bench power supply. So this is the same bench power supply that featured in the video recently, where I fitted the new full bridge rectifier. so I've got 26 volts. And if we switch on, hey, so at least the backlight is on. Right, so you can twist this to change the output voltage on this one. Okay, I haven't yet looked at the manual to see how to work this. It's got a clicky button as well to switch the output on and off. Right, so despite the best efforts of the postal service, this is actually working, so that feels good. So let's have a look at the USB PD board. So you got the output side here, which looks like it should have some kind of terminal block on it. There wasn't one that came with it. So I'll have to have a hunt around, see if I can find something suitable. I don't know if it'd be a good idea to solder wires directly in here. Anyway, so there's the only control is this switch here, which so you've got high and low, and depending on what you select you either get 20 volts or 15 volts. So I'm going to want that at 20. Let's try that side. So first of all, I might put just a kind of standard USB in there before I try and use the PD. Let's see, what have I got? So I've got a cable here which is sort of conventional USB type B, is it called? And then, or is that the A end? I can't remember. But then there's a USB type C on this one, so we'll plug that in. Alright, so we've got a red LED on, and the setting of that switch doesn't really matter. So this should only be 5 volts in at the moment. Just put the meter in there. Alright, the power bank's gone off. Let's press the button again. There we go, so we've got about 5 volts out. So the red LED probably tells us that it's 5 volts. So next I've got this Belkin power supply which has got some limited PD functionality. So this says 9 to 12 volts. Well, it says 5 volts, 6 to 9 volts, 9 to 12 volts. So this is kind of part of the PD spec. So plug that in over here. See what this does. Okay, so once again we got the red LED. doing very well here. It seems to be wandering around, doesn't it? What's going on there? Oh, there we go, 5 volts. Let's flip the switch. Still red lead. And 5 volts. Right, so obviously this board can't support the 12 volt mode, so it stayed in 5 volts mode. So let's try the so I have a laptop power supply which should have the full PD functionality. So this is quite a compact unit. It's an HP one. It's quite nice. So I'll plug this into the board. Oh, now we get a blue LED. And the voltage has gone up to 20. There we go. And if we flip the switch, it's now kind of purple LED. And that's the 15 volts. There we go, 15 volts. $20 volts. Right, pretty neat. So we have the functionality that we need. So I'm going to leave that switched in the 20 volt setting. And so if I can find a terminal block for this, I can start assembling and see if it'll fit in that little plastic case that I've got. I couldn't find just a two-way block, but I've got this three-way. So what I was thinking is I'll plug it in like this with it slightly overhanging, and then I can bend that last pin in and connect it to there, which should be the ground, and then I'll end up with two grounds side by side, which will be less likely to short out on something. So I'll do that. Right, so I've got that soldered in place now. So the two right hand ones are both grounds, and then that's the plus output on the left. So that should be good. Now I found some wire, so I've got this this mains wire, which should be suitable. I just checked the HP power supply provides about 3 and a bit amps, so it's 65 watts. So we should not have to deal with more than 3 amps of current. So this multi-stranded wire should be capable of carrying that current, so I'm going to use that throughout. Right, so this is where I've got to so far. So I've got a couple of wires on the output side, all tinned and ready to go. So I'll find some tags, some solder tags I think, and attach those to here, but I won't do that until it's all going into the box. And on the input side I've got some more wires that I tinned and cut to length so that they clamp well in here, and these are going into the USB PD module. So brown for positive, going down through the switch here, and then the blue going directly into the negative side. So I could do a quick test now. Make sure that's actually doing something. So we'll plug in the USB. It's gone blue. Got something wrong here. not actually lighting up. What's happening? Right, let's see what's occurring. So, do we have voltage on here? Voltage seems to be jumping around a bit. Doesn't seem entirely good. Let's just take these wires out for a second. It is jumping around strangely. I wonder what's gone wrong here. I mean, it does look like it's correctly soldered. Well, there we go. Maybe it's something to do. Maybe my multimeter was playing up, but that looks like it's reading 20 volts now. So let's check that's the positive side. Yeah, in positive. Nothing coming from there. We'll put this on the power supply again. Whoa, there we go. I must have this switch wired wrong. That's what the answer is. I've got the wrong wire soldered on there. I was sure that I checked that. Whoops, I'm shorting stuff out there. Just check that's right. Yep, seems good. Okay, we'll go again. There we go, that's more like it. Actually lighting up now. Right, so that's all the basic building blocks. The next thing is really to start drilling holes in the case and seeing how to fit that in. I do intend to put a fuse in here as well, in case this thing shorts out. I don't want it shorting out the input power supply, the USB-C. But that's in the post at the moment. I haven't received the fuses and fuse holders yet. Right, I was going to use this as the enclosure, but I think it might be a bit of a squeeze to get everything in there, especially since everything has to go through the front hole here, and see, this doesn't leave much space for putting the jacks in there. So what I decided to do instead is I bought this enclosure. So I'll show you that. So enclosures often turn out to be one of the most expensive parts of any of these kits. I think this one was over £10, which is, you know, comparable to the, you know, the buck boost converter here, which is the most expensive active component here. But you see, this is probably going to be quite nice. It's got a black panel that you can use for the back, well, or the front I guess, but I think the red perspex is meant to be a front panel. So you can see that this is going to leave a bit more room, so then I can have the boost converter through the panel. I can have the jacks. Maybe I can even squeeze the on-off switch in there, although that is quite a big diameter, but we'll see. So I'm going to sort of measure things and start mapping things out and start cutting a few holes.